Hope all of you are well. So today we are going to discuss one of the most important topic from the Laplace transformation, that is the convolution theorem, and using the convolution theorem how we are going to find out the inverse Laplace transformation. This is one of the most important and applicable in many engineering problem. So let us start our today's discussion. So before we go to the problem, first of all we need to know about the convolution and the convolution theorem. So what is the convolution between the two functions? Suppose we are having two real valued functions f and g, and these two functions are considered as some integrable function defined over a interval, closed and bounded interval 0 to t, where t is a positive real number. Then the convolution of f and g is usually denoted by this symbol, that is f star g, and it is defined as f star g equals to integration 0 to t f of u g of t minus u du. Okay, so similarly you can define the convolution between g and f function also. Always remember one thing, the convolution between f and g and the convolution between g and f both are same. So whatever function you treat it as the first function or the second function, that does not change the value of the convolution. Now how this convolution is related to the Laplace transformation, let us try to understand the convolution theorem. So now suppose we are considering the Laplace transformation of a function f of t as capital F of s, and the Laplace transformation of g of t equals to capital G of s. Okay, so now what will be the Laplace inverse of fs into gs? So if we are having some product type of function fs into gs, whose Laplace inverse we have to calculate, then it can be done using the convolution of f and g. So it will become ft star gt, convolution between f and g. So in the formula of convolution of f and g, just I have told you, it is equal to 0 to t f of u g of t minus u du. Okay, so the integration will happen with respect to the variable u, and t will be considered as a constant inside the integration, and u is the dummy variable for this integration. Now let us come to apply the convolution theorem to do some questions which are very important for our exam. So you suppose the first question is, using convolution theorem let us try to find out L inverse of s upon a square plus a square whole square. Okay, so now in place of a square you can have some real value also, but the problem structure will be same. So to make the problem general, I have chosen a here. In exam you can have 2 square, 3 square, 4 square, this type of object. Okay, so as per that you have to change the problem procedure. Now how to apply this in the question? So first of all we have to look at the inside function of L inverse, whose L inverse which we are going to evaluate. So that is s upon a square by a square whole square. So can we write down this function as a product of two function, or can we split it? Yes, we can split. So what are the two functions we can have? One function will be s upon a square plus a square, another function is 1 upon a square plus a square. Now these two functions will call as fs into gs. Here again I am saying it is not necessary that s by a square plus a square you have to take as fs, 1 by a square plus a square you have to take as gs. You can swap the functions also, but the answer will not get changed, as convolution is always commutative. Now what is our fs? As per our assumption we have considered fs as s by a square plus a square. Now we have to do the first thing, that we need to calculate the L inverse of f of s. So L inverse of f of s is L inverse of s by a square plus a square. Now I think all of you know some formulas of the Laplace transformation. So s by a square plus a square, it is coming from the function cos at. So L inverse of this is nothing but cos at. So we considered this function as ft as the first function. Similarly, 1 upon a square plus a square, we have to take the Laplace inverse, and the result will come as sin at upon a. So we consider this as the second function, that is g of t. Now we need to apply the convolution to find out L inverse. So we need to write down the convolution theorem first, that is L inverse of fs into gs, that is equals to f star g, convolution of f and g. So let us calculate the convolution now. So f star g is 0 to t f of u g of t minus u du. Since ft is our cos at, so we have to write down cos au, that t we have to replace by u, and g of t minus u, since our gt is a sin at, so in place of t we have to write down sin of a into t minus u divided by a du. Now we have to break this sin of a minus t, a into t minus u part. Okay, so because we know the formula for sin of a minus b, and that is equals to sin a cos b minus cos a sin b. So using this formula we have break sin of a t minus u. So basically there are two terms, sin of at minus au. So we can split it as sin at cos au, that is sin a cos b, minus cos at sin au, that is cos a sin b. Now since the integration is happening with respect to the variable u, so we can treat t as constant. So t related term we can keep it outside, so sin at is going outside, so inside we are having 0 to t cos square au du, and from the second integration cos at can be taken outside, integration will be 0 to t cos au into sin au du. But inside these two function, that is cos square au, is not in the form that we can integrate it. Okay, so we have to make it into a double angle formula. Similarly, this part also, it is not in a form that we can integrate it, so we have to make it into the double angle formula. So for that we have to just divide this term outside by 2 and multiply 2 to adjust it. Okay, so 2 cos square au, similarly cos at divided by 2 and multiplied with the 2, so it is getting adjusted. So nothing is we are doing something new, we are just multiplying and adjust it by multiplying outside by 1 by 2. So after doing this, we know the cos double angle formula, that is cos 2 theta equals to what? That is equal to 2 cos square theta minus 1, and sin 2 theta equal to 2 sin theta into cos theta. So 2 cos square au we can write it as 1 plus cos 2 au du. Similarly 2 into cos au sin au, so it is acting like a cos theta sin theta. 2 cos theta sin theta is nothing but sin 2 theta, so it will come as sin 2 au du. Now we have to do the simple integration. So integration of 1 with respect to u, it will become u, thereafter it will come plus cos 2 au, integration is sin 2 au upon 2, limit is 0 to t, minus cos at upon 2, integration of sin 2 au is minus cos 2 au by 2a, in limit is 0 to t. So simply we have to substitute the limit and little bit simplification we have to perform. So here sin at upon 2, it is outside, In place of u, we have to put upper limit as a t plus sine 2at by 2a minus cos at by 2, and when we put the upper limit, it will come minus cos 2at by 2a minus of minus cos 0 is 1, so it will become plus 1 upon 2a. So many times students make mistake, they forget to write down this term because here cos is coming. So while putting the lower limit 0, you should be very careful, don't make any mistake in the exam like this. So now whenever we will open the bracket, what we are getting here, t into sine 80 upon 2, 1 by 4a sine 2at into sine 80 plus 1 by 4a cos 2at into cos 80 minus cos 80 upon 4a. Now this two term, if I take 1 by 4a common, so we are getting sine 2at sine 80 cos 2at cos 80. So basically it will come from another trigonometric formula, that is cos of a minus b. What is cos of a minus b? That is cos a cos b plus sin a sin b. So compact form is cos of a minus b. So here a is our 2a, b is our 80. So cos of a minus b will come 1 by 4a cos of 2at minus 80. So after doing this, we are having 1 by 4a cos 80. Another term is there, minus 1 by 4a cos 40. So these two terms are basically going cancelled out. So what is our final answer? That is t sine 80 upon 2a. So this is the process by which we can find out the convolution of the Laplace inverse. Let us do another problem. It is little bit lengthy compared to the previous one, but it is important also. Let us try to understand. Using convolution theorem, find out L inverse of a square upon a square plus a square plus b square. So first of all, we need to write down the inside function, whatever it is there inside L inverse, as a product of two function. So a square by a square plus a square into a square plus b square can be written as a upon a square plus a square multiplied with s by a square plus b square. So we can think it as product of two function, that is fs into g of s. So here fs is what? Fs is our s by a square plus a square. So we have to take the L inverse of this term, L inverse of s upon a square plus a square, that is nothing but our cos at. Similarly, gs is also the same function, but in place of a square we are having b square, so keep it in your mind. So the result is going to be cos bt. Now it is your choice, whatever function you want to treat it as ft and whatever you treat it as gt. There is no rule, you can take any one, your answer will be same. Now we have to write down the convolution statement, that is ft L inverse of fs into gs is what? That is f star g, and formula is 0 to t f of u g of t minus u du. Since our ft is a cos at, so it will become cos au. gt is our cos bt, so it will become cos of b into t minus u du. Now here we have to apply the formula of cos bt minus cos bu. So what is the formula for cos of a minus b? This is coming in this structure. So the formula for this is cos a cos b plus sin a sin b. Okay, so we are having cos bt cos bu, sin bt sin bu. Now from here you can understand integration is happening with respect to du, so t related term we can take out of the integration. So from the first integral we can take cos bt out, and from the second integral we can take sin bt out. So we are having two set of integration. First one is cos bt 2 cos AU cos BU sin BT cos AU sin BU. But cos AU cos BU is not in the shape of that integration. We have to adjust it by multiplying 2 inside and adjust by outside 2. So here we have multiplied 2 and outside we have adjusted by 1 by 2. Here also for the same thing we have to do. Now what will be the advantage after doing this? Here we are getting 2 times of cos A cos B formula. So 2 times of cos A cos B, that is can be simply done from this formula. So 2 times of cos A cos B, basically this is equals to cos of A plus B plus cos of A minus B. Okay, so we are having cos of A plus B into U, cos of A minus B into U. Similarly, from this part what we are having, cos A sin B, 2 times of cos A sin B. So the formula for this is sin of A plus B minus sin of A minus B. Okay, so we are having sin of A plus B into U minus sin of A minus B into U. So we can now integrate. The integration will be simple now. So what is the integration of cos of A plus B into U? That is sin of A plus B into U by A plus B. Similarly, cos of A minus B into U will become sin of A minus B into U by A minus B. Limit is 0 to t. Similarly, for the second integration, sin bt upon 2, integration of sin is minus cos. So sin of A plus B into U, it will become minus of cos of A plus B into U by A plus B, and minus of sin of A minus B into U. Since sin integration is minus cos, so this minus can be taken as plus cos of A minus B into U by A minus B. Limit is 0 to t. Now we have to substitute the limits. So after substituting, we get from here sin of A plus B into t by A plus B, and here sin of A minus B into t by A minus B. And from the second integration, for putting upper limit, we are getting minus cos A plus B into t by A minus B and cos of A minus B into t by A minus B. But while putting the lower limit, that is 0, then what we will get, cos 0 is 1, so minus of minus 1, it will become 1 upon A plus B, and here also it will become minus 1 upon A minus B. Okay, because cos, so while putting the lower limit 0, you have to be very careful. Now to simplify this, we have to remember the following steps, otherwise your calculation or the result will not come as a good result. So what we have done here, we have seen some of the terms are coming with A plus B. So here to A plus B is coming in the denominator. Here also A plus B is coming in the denominator, where some cos and sin structure are coming. So 1 by 2 times of A plus B, 1 by 2 times of A plus B, I have taken common. So what we will get in the inside, that is cos bt into sin of A plus B into t, and from here sin bt into minus of cos of A plus B into t into sin bt, right? Similarly, we have taken 1 by 2 A minus B common. So here one A minus B structure is there, another A minus B structure is there. So I have taken 1 by 2 times of A minus B common. So what we will get, cos bt into sin of A minus B into t, and from here also it will become plus, that is sin of bt into cos of A minus B into t, and plus another term will be there. So this term will be multiplied with this constant. So sin of bt by 2 I already is outside, 1 upon A plus B minus 1 upon A minus B. If we adjust with 2 the LCM, and it will come in this structure. So from the first bracket term, that is sin of A plus B into t cos of bt minus cos of A plus B into t sin of bt, it will come from the formula, that is sin A cos B minus cos A sin B. So sin A cos B minus cos A sin B. So this can be written as sine of A minus B. So here we have considered A plus B as A and B as B. So it will come sine of A plus B minus B into T. Similarly, from the second term, that is cos Bt sine of A minus B into T, sine Bt cos of A minus B into T, it is coming as sine A cos B plus cos A sine B. So it will be simply sine of A plus B. So it will come B plus A minus B into T. And here, after doing the simplification, we get B into sine Bt by A square minus B square. So obviously here it is coming sine AT, also here it is coming sine AT. So 1 by sine AT by 2 you can take common. So these two terms can be adjusted. That is 1 by A plus B plus 1 by A minus B. After simplification, we get this term A by A square minus B square sine AT minus B by sine BT by A square minus B square. So if you do the LCM, what is our final result? That is A sine AT minus B sine BT by A square minus B square. Whatever your choice will be for FT or GT, the answer will be same as it is. Now let us come to another one. Apart from the sine cos problem, we can have some simple type of problem also. Let us try to understand. So use convolution theorem. We have to find out L inverse of 1 upon S plus 1 S minus 3. So here also two terms are being multiplied in the denominator. So we have split it as 1 upon S plus 1, 1 upon S minus 3. So it is treated as Fs into GS. Now Fs is what? 1 upon S plus 1. So L inverse of Fs is 1 upon S plus 1. That is equal to e power minus t. So this will be as our function f of t. Now what is our GS? That is 1 by s minus 3. What is L inverse of 1 by s minus a formula? That is equal to e power at, because all of you know Laplace transformation of e power at formula is 1 by s minus a. So using this only we can go L inverse. So L inverse of 1 by s minus a, this is going to be e power at. So using this one only we can calculate ft as well as gt. So again I am telling, whatever your ft or gt you can choose by yourself, that is immaterial. Now let us calculate L inverse of fs into gs. That will be f star g, that is equal to 0 to t f of u g of t minus u du. So we have to put t by u and in g t by t minus u. So it will come e power minus u. Here it will come e power 3 times of t minus u, since we are having e power 3t there. So e power 3t will taken as outside because it is independent of u. So inside what are the remaining terms? E power minus u into e power minus 3u. So it will become e power minus 4u. Integration of e power minus 4u is e power minus 4u by minus 4. We have to put the upper limit as a t, lower limit as 0. So after putting upper limit t and lower limit 0, what we are getting? The answer is going to be e power 3t by 4 into 1 minus e power minus 4t. So with this, the convolution I am going to close. Convolution is having some limitations. You can understand what are the limitations. First of all, the limitation for convolution is that it is applicable for two function. That is, in the denominator, if we are having two products, then it is easy to do the convolution. But if more than two functions are coming in the denominator, more factors are there in the denominator, convolution theorem will not work properly, or the calculation will get more complicated. Second thing is that here for convolution, every time we have to do the integration. So if your integration capability is not good, then there will be some problem. So to do the convolution problem properly, you have to be very good in the integration, so that the formulas of the trigonometric or the polynomials, sometimes we have to do substitution also, sometimes we have to do by parts also. So all those techniques you have to know very well, otherwise the convolution can be difficult for you. So in the next lecture we are going to discuss finding Laplace inverse using the partial fraction method, which will be more advantageous in comparison to the convolution theorem. So thank you all.